I will use this video to explain how to calculate probability involving a binomial random variable. Okay, so let's look at here. The probability mass function of a binomial random variable x with parameter n and p. So notice for binomial random variable, so there are two parameters, n and p. Okay, so if we want to know the probability that x equal to k, so basically, so this formula just lists how to calculate the probability. Okay, and the first part, so this is called n choose k. Yeah, n choose k is defined here, and let's explain how to calculate here. Yeah, so this one may look complicated. Okay, so the numerator is n factorial and the denominator is n minus k factorial times k factorial. In fact, usually, so if we want to do the calculation, we will use this formula instead. You can see, so this is a ratio of two parts, right? I mean, two product. So numerator involves the product of k integer, and so counting down from n. You can see n minus 1, n minus 2, n minus 3, and you counting down to n minus k plus 1. And so denominator also the product of k integer. Yeah, but we count up from 1. So 1, 2, 3, 4, up to k, right? So let's try an example. So suppose we want to calculate 10 choose 4. Okay, yeah, so 10 choose 4. Both numerator and denominator will be product of 4 integers. From the numerator, we counting down from 10. So 10, 9, 8, 7. See, we have 4 number, right? We have 4 integer, right? So this 4 indicate the numerator has 4 integer. And so this 10 is this 10, right? So basically we counting down from 10. So the numerator will be 10, 9, 8, 7 times together. And for denominator, 1, 2, 3, 4. So we counting up, right? So counting up from 1. And so because this is 4, so basically the denominator, we have 4 integer. Okay, after that, so then you can do the math and to find out so what's the value it is, right? Okay, notice a special case. 0 factorial is defined to be 1. So basically, so this just means, for example, if you want 10 choose 0, see, by definition, right? So this is 10 factorial, see, n minus k will be 10 factorial and 0 factorial, right? And so 0 factorial equals to 1. Okay, so this is 1, right? And 10 factorial cancel out. So basically the value is 1. So basically, no matter what value n is, n choose 0 is always 1. Yeah, so you can memorize this as a formula. Okay, so now let's see how to use this probability mass function to calculate, to solve this problem. Suppose that one rolls a die 10 times, find the probability of the following events. Yeah, you can see, so the following events, so just want to know, so exact 1/6 or at most 2/6. So basically just want to find the probability of the number of sixes. Okay, yeah, so if we denote x to be the number of 6, okay, yeah, so x will follow a binomial random variable. And so for binomial variable, so it has two parameters, right? So we have n and we have p. And for n will be 10. Yeah, because we roll the die 10 times. Okay, so the number of 6 can be 0, can be 1, and up to 10. Yeah, because we roll the die 10 times, right? So n will be 10. So p is just the probability of getting a 6. So if we roll the die once, okay, yeah, because a die has a 6 sided, okay, so p will be 1 over 6, right? Okay, so now let's check how to solve this problem. Okay, exact 1/6, exactly 1/6, right? Yeah, so this is just the probability x equal to 1, exactly 1/6. Okay, so now let's try to apply the formula for the probability mass function. Okay, so in this case, notice so n. So n equals to 10, p equal to 1 over 6, and k equal to 1, right? So then you apply those numbers basically to here. Also, sorry, basically to here, right? So to the probability mass function. So then you will know this is 10 choose 1 times 1 over 6 to the power of 1, and 1 minus 1 over 6 to the power of n minus k. Okay, so now let's try to evaluate the value. So 10 choose 1, we can see, so 10 choose 1. So this is a ratio of two product. Because this is 1, okay, so basically both numerator and denominator only involves one integer. So the numerator counting down from 10, yes, will be 10, because this is 1, and so we have just one integer. And the denominator we counting up from 1, okay, so one number. So this is 10, right? So okay, so we got 10 times 1 over 6 to the power of 1. Yeah, so then 1 minus 1 over 6 is 5 over 6 to the power of 9. Okay, so then you can use your calculator to get the value. So this is 0.3230. Okay, yeah, so this is the probability that we will get exactly 1/6 if we roll the die 10 times. Okay, so now let's try the second one. I will erase this first. Oh, I will erase this first. So let's try the second one. Okay. The second one, so this is at most 2 6s, right? So basically, so this is the probability at most. Okay, so x smaller than or equal to 2, right? Okay, and so then this is basically the possible value. So the smallest possible value will be 0, and so then 1, then 2. In fact, p smaller than or equal to 2 just implies that the value of px can only be 0, can be 1, and can be 2. Okay, so for this three part. Okay, so basically we use the probability mass function to calculate its probability and then add them together. Okay, so for the first one, so basically 10 choose 0 times 1 over 6 to the power of 0, 1 minus 1 over 6 to the power of 10 minus 0 plus. For the second one, k is 1, right? So 10 choose 1, 1 over 6 to the power of 1, 1 minus 1 over 6 to the power of 10 minus 1, plus 10 to choose 2, 1 over 6 to the power of 2, 1 minus 1 over 6 to the power of 10 minus 2. Okay. We just mentioned, and so 10 choose 0, so the value will be 1. And so 1 over 6 to the power of 0, so this value is also 1. Okay, so then we got 5 over 6 to the power of 10. And then plus, for the first part, so for this part, so we just explained how to calculate that, right? So this is 0.3230. Okay, so then we plus, for the last one, 10 choose 2, right? See, 10 choose 2, okay, yeah, because, so this is 2, right? So it means numerator and denominator, so both involves 2 integers. So the numerator, we counting down from 10, so basically 10 and 9, and from the denominator, we counting up from 1, so 1 and 2. Okay, so you do the math, so this is 45, okay? Yeah, so basically times 45 times 1 over 6 to the power of 2 and 5 over 6 to the power of 8. Okay, yeah, so then after that, so then you can do the math, and so then you will get the probability will be 0.7752. Okay, yeah, so then we will say the probability that at most 2 6, so will be 0.7752. Okay, let's continue and try to see the next one. Let me erase this one. Okay, yeah, so now this one will be less than 2 6s. So this is probability that x less than 2. Okay, so there is no equal, right? So less than 2. Yeah, so basically, so this is, because we mentioned, so the possible value of x will be 0, 1, 2, 3, up to 10. And so x smaller than 2, and so the only possible value of x will be x equal to 0 plus x equal to 1. Yeah, and we've already explained, right? So basically, so this is basically, so 10 choose 0, 1 over 6 to the power of 0, 1 minus 1 over 6 to the power of 10, plus 10 choose 1, 1 over 6 to the power of 1, 1 minus 1 over 6 to the power of 10 minus 1, right? And so basically you can do the calculation and you get the probability will be 0.4845. Okay, yeah, so you can complete the calculation. I mean, you can fill in the details by yourself. Okay. Let me erase this one. Okay. So the next one is at least 2 6. At least 2 6s. So this is basically probability x greater than or equal to 2, right? Yeah, so notice, so if the problems involves at least, in most cases, and so we will just try to consider the complement first. So basically, if we know 1 minus probability x smaller than 2, okay, so then we will know use basically 1 minus probability x smaller than 2 will give you the answer, right? Okay, so basically, so this is just 1 minus. In fact, we've already explained so what is how to calculate this one, right? Or if you write it out, basically you just need to calculate 1 minus probability x equal to 0 minus probability equal to 1, right? Yeah. Okay, and so the remaining steps are ignored, and so you can try to complete by yourself. And so the next one, the last one. The last one is at least 2 and at most 4 6s. So this just ask at least 2 means greater than or equal to 2, but smaller than or equal to 4, right? So then you just still, I mean, just try to first figure out, so what are the possible value of x? So the value of x, so can be 2, can be 3, and can be 4, right? So for these 3 probability, you just add them together, right? And so you apply the formula. So 10 choose 2, 1 over 6 to the power of 2, 1 minus 1 over 6 to the power of 10 minus 2, plus, see for this one, 10 choose 3, yeah, because this 3 is just the k as in the formula for the probability mass function, right? So 1 over 6 to the power of 3, 1 minus 1 over 6 to the power of 10 minus 3, and plus 10 choose 4, 1 over 6 to the power of 4, and 1 minus 1 over 6, 10 to the power of 4, right? Yeah. See, this one, so in the previous example, so we've already explained, so why this is equal to 45 times 1 over 6 square times 5 over 6 to the power of 8. Yeah, so let's maybe just try to see as another example, right? Just explain how to evaluate this one. See, this is plus 10 choose 3, right? So 10 choose 3, okay. So basically this is 3, okay. Numerator involves 3 integers. Also counting down from 10. So 10, 9, 8. So 3 integers, right? And so denominator, we counting up from 1. So 1, 2, 3. Okay. So you do the math. So this is 120. Yeah. So basically this is 120 times 1 over 6 to the power of 3 and 5 over 6 to the power of 7. Yeah, so similarly, so 10 choose 4, right? So this is 210 times 1 over 6 to the power of 4, 5 over 6 to the power of 6. Okay, so you can use a calculator basically to get the value. So the value will be 0.5000. Okay, so this is the probability of at least 2 and at most 4 sixes.